Whoops. Hi there, everyone. Welcome to another burst session. This session is focusing on computational fluency in kindergarten through grade 5 with a focus on instructional routines and how they can develop computational fluency, or a part of that, that whole package of things that we do to support computational fluency. My name is Janice Nowakowski, and I'm the district teacher consultant for mathematics and numeracy in the Richmond School District. So again, for those of you that are joining for the first time, we are doing a whole series, and I do want to begin with a bit of an overview of what computational fluency is. Computation itself is the calculation with numbers using operations, so addition, subtraction, multiplication, and division, which are all introduced across kindergarten through grade 5. And then when we think about what computational fluency is, it's having efficient, flexible, and accurate methods for computing. So it's having multiple strategies and bringing flexible thinking about numbers and the operations to those strategies and to the computation. So when we think about fluency, is being able to do computation in multiple ways, so more than one, more than two ways, and being flexible in our thinking about what strategies we might use for different questions. And then, of course, accuracy in our solutions is an important part of computational fluency in mathematics. This isn't estimation. This is actually finding the answer and the solution to the question. So where does computational fluency live in our curriculum? It's one of the 5 big ideas across kindergarten through grade 9. When you go to the website, it's the second one. So number concepts is first, and then computational fluency or operations is second. So you can see here the meta idea that crosses K to 9 is that computational fluency develops from a strong sense of number. Students can't be fluent with computation if they don't understand place value or how numbers relate to each other. Also, under that big idea, there are some inquiry questions to support investigations with computational fluency. So, for example, in grade 4, what is the relationship between multiplication and division? What patterns in our number system connect to our understanding of multiplication? So, some of those big meta questions that you can explore across the whole year are there for you under those big ideas around computational fluency. Here's the addition and subtraction continuum that starts in grade 1 with the introduction of the concept and the processes involved with addition and subtraction. Multiplication are introduced and division are introduced in grade 3 and have a similar 5-year continuum where students are expected to become more fluent with their strategies, their efficiency, and their accuracy over time. So that flexibility and that fluency develops with more practice over the grades. So today we want to focus on that one element of practice and developing computational fluency through instructional routines. So instructional routines provide a known structure. So students, when you say we're going to do a number talk, they know what that means. So teachers and students can get to doing the math and talking about the math right away instead of having to explain the logistics or the instructions for the task. So it's one of those known structures that can be used across the grades, kindergarten through grade 9. Most of these routines can. And so students know what to do and can get right to the math right away, which is really important. Instructional routines are also responsive. As the teacher, you're noticing what students are doing one day, and then in your routine, for your next math lesson, the next day, you're like, oh, I noticed that they're really having difficulties with this, or they're not many students are using this particular strategy. I'm going to choose a question that's going to nudge them to get to that particular strategy. So you can be responsive to where students are and move their learning and their strategy use forward. Instructional routines are also inclusive. They are one of those, low floor, high ceiling kinds of tasks where there's access points for all students in the class. And as the teacher, you're designing, the numbers or the questions that you choose so all students can access, at least the initial question or one of the questions in the routine. One of the lovely things about instructional routines for BC is that they also develop our curricular competencies in math across kindergarten through grade 9. So explaining and justifying solutions, communicating mathematical thinking in many ways, using mental math strategies. All those competencies also provide an access point for some students. So if the numbers are, maybe far beyond what a particular student is working with. You have a grade 4 or 5 class and you have a student who's working with numbers to 20, they can still access the competencies of communicating mathematical thinking or using a mental math strategy, even if it's with lower numbers. So the instructional routines are generally inclusive in that way. And then the instructional routines that I'm going to share today that focus specifically on computational fluency, they create those opportunities for practicing strategies, explaining and justifying solutions, and making those connections between numbers and operations. And so that students, again, are flexible and fluent and can move backwards and forwards with different numbers and different operations and see those relationships. The other competency that's highly developed in many instructional routines is that having students make that connection between visual and pictorial representations of quantity or operations, and then those symbolic representations as well. And so often there's scaffolds that are provided, whether it's an image or whether it's 10 frames, on the board or an array of some sort that are, again, supporting students in making those connections and thinking about connections between operations and numbers. An example of that, using sort of a visual support, is number talk images. And I'm just going to quickly go over some routines, instructional routines that support computational fluency. So if you're not familiar with number talk images, we have a full burst video on that, but the website at the bottom there is ntimages.weebly.com. And you might, with your younger students, and I've used this with older students too for, equation writing, is put up those ducks. How many ducks and how do you know, or how do you see them? And some students might count. Some students might see it as 6 plus 5. Some students might see it as 3 times 4, subtract 1. So again, there's that opportunity for fluency with different operations and seeing it in different ways. So it's not just about knowing that there's 11 ducks. It's about how can we see that there's 11 ducks, and how can we describe that with words, with symbols, with different pictures, etc. And then you can record the different ways that students share how they see those ducks. On the right, you see 2 arrays that are intersecting. And so on the website, there's photo images and there's also dot images. So this on the right is an example of a dot image. And students are going to see that in different ways. They might share, well, I see there's 5 along the across the middle, and then there's 2 times 6. So that's 2 times 6 is 12 plus 5 is 17. Other students might see it as, oh, well, it's 3 by 3 and 3 by 3. So that's 9 and 9 is 18, but 1 is shared. So I'm going to subtract 1. So that's 17. Other students might do 3 plus 3 plus 3 plus 3 plus 3 plus 2. So again, an opportunity at access points for different students to enter and offer a way that they see those dots using addition or using multiplication, using arrays, etc. Number talks is probably the foundational instructional routine for developing computational fluency, and is one of those routines that you need to do all year long. So students are developing and hearing other students share an understanding of different strategies. So essentially in a number talk, students are presented with a question to solve using mental math strategies, and they justify their solution. So for example, on the left, this would be sort of a grade 2 question, 48 and 37. And then what are all the different ways you can solve that? As the teacher, you're recording the students' different strategies. And some of them might say, well, I visualized this, or I jumped in my head, and you use the open number line to show that. Some of them will say, I decomposed by place value. Or some of them might say, well, I did 40 and 8 and 30 and 7. And that's where you as a teacher can help provide some of that mathematical language. Oh, in math, we call that decomposing by place value, which is the most common way that they add like this. Again, those 10 frames are up there to support as a scaffold for them thinking about 8 and 7 and how that's connected to 48 and 37. On the right, you see an example from a grade 4 class or grade 5 class where we were doing addition and subtraction with decimal numbers. And again, same kind of number talk, and you're recording the different ways that students might do that. They might know the traditional algorithm that we use in North America. There's many different algorithms. And my opinion and my feeling around this is that you honor, if students share that, you honor that, but you have them explain what they're doing and check for their understanding to see if they understand the place value of the numbers that they're talking about and why they're doing what they're doing. But that having one of those algorithm strategies is not enough to be proficient in our curriculum. You have to have multiple strategies and be flexible with the strategies that you're using. So you can see some of the other strategies on the right, for example, compensating, that you might use with whole numbers that you can then also use with decimal numbers as well, and then fractions when you're in grade 8. So again, at the end of a number talk, students might compare and analyze the different strategies that have been shared. And as a teacher, you might ask them to think about, okay, now we're going to move into practicing some questions like that. Think about one of these new strategies that you've heard from a classmate, and why don't you practice that today? At the bottom of the slide, you see some different resources around number talks. These are either available in your school libraries as professional resources, or they are available through our district resource center. Primary ones on the left, this one is sort of kindergarten through grade 5, and then the ones on the right are sort of grade 2 and up through grade 7 through grade 8. Another routine that supports computational fluency is SPLAT. Now, SPLAT is very much about algebraic thinking, but it also integrates all the operations. So students can use addition and subtraction, multiplication and division to think about it. And again, so it really nurtures that flexibility with the different operations. So essentially, if you look at the one on the left that has 18 beside it, you have a SPLAT and you know how many blue dots there are in total. That's the number in the box. There's 18. You see that 3 are on the outside, so you have to figure out what is underneath the SPLAT. So again, some students might go 18 subtract 3 is 15. Other students might think what plus 3 equals 18. So using that addition and subtraction. On the right, when there's multiple splats that are all the same color like this, when they're all black, it means they have the same number underneath it. So again, a student might think, okay, well, there's 22 total dots. I see 4. So I could subtract 4 from 22, which gets me to 18. And then I know 3 times what equals 18, or 18 divided by 3 equals how many are under each splat. So again, students might share different ways, again, in justifying how they know how many are under the splat. If you haven't used splat before, you can go to the Steve Y. Burney website at the bottom of the slide there, and you can download all of these slides. He provides them freely, which is lovely, in Google Slides or PowerPoint slides, and all the transitions are built in for you. And they build in complexity, a single splat to multiple splats to fraction splats, etc. And then the last routine I want to share is numberless word problems. And this again really focuses on those operations and students thinking about what they mean flexibly. So at the top, we have an example. This was in a grade 3 and 4 class. And on the left is the numberless word problem. So it's a word problem in a structure, but it doesn't have the numbers yet. So when it's first presented to students, there's no number. So there were some carrots growing in a garden. They were growing in rows. Each row had the same amount of carrots. So, we'll ask students at this point to pause and make a picture in their head of what that garden looks like, or play the movie. And it's about focusing on the mathematical structure of this problem or this math story to help them think about what they're going to need to figure out and what they're going to need to do, instead of just grabbing the numbers and doing something with it. You slowly, with each slide, or if you do it on the poster paper, or I do it on the whiteboard and just erase, the sum or the same amount and put the number in. But you can see I've got slides here on the right. So eventually we get to when they have enough information to solve. There were 36 carrots growing in the garden. They were growing in rows. Each row had 12 carrots. And then I'm not going to give them the question. Maybe at the beginning, the first time we do this, I might model the question, but I'm going to ask the students, well, what math question could you ask? Like, what is it that we need to figure out? We've got 2 numbers. What are we going to do with them? And that's quite difficult for many students, especially when they're used to being provided with the question all the time. So that's one of the lovely things about numberless word problems, is it really gets students thinking about those operations and about the mathematical structure. And then on the right, you can see how I'm recording the different ways students thought about it, what the questions they came up with. And just like a number talk, then you're sharing and recording the different strategies. If you haven't heard of numberless word problems before, we do have a burst session available on the YouTube playlist on numberless word problems. And then the numberless word problem website is at the bottom of the slide. So when thinking about how to use instructional routines in the classroom, we generally use them as an opening routine to activate prior knowledge, to build mathematical language and strategies, and to engage in mathematical discourse as a whole class. So building that math community. But you can also use them in the main part of the lesson as a practice task. If you do a math workshop or centers or stations, if you've done a number talk image at the beginning, then you might have number talk images printed out at a table that students can circle with pencils, or think about the different ways that they see it, or they might have splats that they create and do as a practice task. I often do number talks as part of small group instruction. So I'll do it with a whole class at the beginning, and then I notice, who might need some development of certain strategies, or who might need some, extension of strategies. And so when I'm working with small groups during math workshop, or, at other times during the day, I'll pull 3 or 4 students and I'll do a mini number talk with them on the whiteboard and have them practice recording the different ways they solved the question as well. And then another, during the main body of the lesson, you could have students create their own routines to share with their classmates. Number talk images are great for that. They could take photos on the iPad, and then you can project them in the classroom the next day for students to solve. They can do splat. They can create their own numberless word problems and create the slides for those that you can then share. They can solve each other's. And then often at the end of a lesson, you can also revisit one of the routines that you've done to bring closure to the lesson and reflect on the learning that you did and what they practiced, and apply and discuss those strategies that they practiced during the main part of the lesson. And as a teacher, you can use that as formative assessment. You can get sort of this class profile as like, okay, we still need to work on this, and this is what we're going to do tomorrow. And then again, of course, that connection to the core competencies. All these routines foster communication and collaboration and developing those particular core competencies. So here's an example of a grade 1 and 2 week plan that is focusing on decomposing quantities, to operate with numbers, addition and subtraction. And you can see how on Tuesday and on Friday, the first part opens with a routine. Tuesday is splat, and Thursday is a number chalk, focusing specifically on addition strategies with decomposing. And then you can see on Tuesday how splat is part of one of the choices for math workshop. So you just might have splats cut out of paper and some counters out for students to do splat with a partner, for example. And then on Friday, again, the number talk is part of the introduction to the lesson, and then you've got some assessment questions and tasks in the middle. We also have a little number talk here on Thursday as part of math workshop. That's the small group work, a mini number talk focusing on addition strategies with decomposing, and that is likely going to inform what questions I might present on Friday to the whole class based on what I'm noticing in small group work. And then this is an example with a grade 4-5 class that visited the studio last year. And the learning goal was multiplication facts for the grade 4s, and then up to 3-digit multiplication with the grade 5s, using mental math strategies. Oh, I've got using there twice, and representing multiplication using concrete, pictorial, and symbolic forms. So we began with a number talk. We actually did a number string, which is a series of 2 or 3 or 4 questions that are related to each other, so that students are building that understanding of the relationship between the numbers. So you can see here we got to 8 times 243, and I've recorded all the different ways students have solved that. On the left here, we've got the different answers. That's often how I'll start with a number talk. It's just I'll go 1, 2, 3, and have them call out what they think the solution is. And then I record all the different possible solutions they think, and then I ask them to prove or justify that solution. And then they explain that, and then they can change their mind after they hear someone else solve a question too. And that's part of the learning and the culture that you need to develop during a number talk. You can see here, these are the questions that after we finished the number talk, I said, okay, now here's 4 questions. You choose one that's a good fit for you. What, numbers that you think you need to practice working on for multiplication. And I want you to solve that question in at least 2 or 3 different ways. And so this is just what it looked like in the middle of the lesson. The students could choose from a buffet of math materials. So they could use concrete materials, they could paint and create arrays, and they could use symbolic notation as well. So we've got students here playing with different strategies and the area model, and then students writing on the windows too, as another surface that they can use to do their calculations and computation. And then we came back to the carpet at the end of the time, and I asked them to share what strategies they practiced and then how they connected their strategies to the different materials or the pictorial forms that they use and how that helped them understand the strategies. So those are just some examples of how routines, become part of your classroom sort of instruction and part of your planning. So again, for more resources on computational fluency for K-2 and 3-5, you can click on the computational fluency tile on the portal. And then these are the grade 3 and 5 examples. You'll see there's a link to the high yield instructional routines videos. And then there's those instructional strategies that are important for developing computational fluency at those grade ranges. Again, on the portal under K-2 and 3-5, there is a tile at the bottom on instructional math routines. That's where you can find a little bit more information, and you can find the posters in English and in French for many of the routines that I've shared today. Also, the School District 38 Numeracy YouTube channel is linked through the portal as well. This is the website if you haven't seen it before. And again, these are all videos ranging from 10 minutes to 20 minutes on those different routines. If you're not familiar with the Coast Metro Elementary Math Project, you can go to coastmetro.ca. And on the first page, there's a little tile for instructional routines for K-7. And here's an example for number talks. A very simple, 3 or 4 or 5 points, I think, for this one. It explains what the routine is, and then some resources, and then some links, and then those connections to the curriculum in BC, so the curricular content, as well as the curricular competencies. So just as we finish up here, just some questions for you to think about. How might you include instructional routines during your week as a form of regular practice to support computational fluency? In what ways could you collect information about student strategy use and computational fluency during instructional routines? So how are you collecting evidence of their learning? And then what thinking and connecting strategies could you use to support students' consolidation of math learning during or after an instructional routine? And we'll be talking about some of these things during our assessment session in a couple of weeks. So thank you for joining me, and we hope that you'll go back to these recordings and share them with your staffs as a form of professional learning and building a culture of how to use instructional routines across the grades in your schools. Thank you.